Welcome back to Leveling Up with Docker. Last episode we left things on a cliffhanger. We deployed cloudbeaver and mysql. They were both running, but cloudbeaver could not reach mysql, and we could not open it in the browser. I said we would fix that in the next episode, and today is finally the day. By the end of this video, we'll know how to expose a container to our browser and how to wire multiple containers together so that they can find each other. Let's fix the most visible problem first. So the cloudbeaver is a web UI. It runs inside a container, but there is no way to reach it from your browser unless you tell Docker to open a pod. The format is actually quite simple. What we need to do is basically saying that we want to actually expose a pod, right, to the container pod. Right. So in this case, we are going to map pod 8888 to 8978, which is the default container pod. So let's go ahead and do it in our terminal now. Let me run it again. So we do this name dt cloudbeaver -p. This is where we are going to listen on. -v data/opt/cloudbeaver workspace 26. Okay, we are running. You notice that now our port 8888 is actually redirected to 8978 TCP. So we can do this, nap, grab 888. You should see this as well. Okay, now our cloudbeaver is ready and listening to port 8888 on our rootless Docker host. I have mapped my rootless Docker host to ldocker earlier, so I'll visit them in ldocker. Let's do this. So I can do ldocker 8888. The cloudbeaver look, the UI is right there. Now let me try to add the database connection. So you need to do this. I'll do this ABC. Because this is a new container, right? We need to actually create all this configuration first. Okay, pgAdmin. Now, before we can actually add the connection, of course, I'll need to actually run the we need to actually run mysql. Let's do that as well. Okay, so we'll do docker run -d name dt mysql root password docker mysql database testdb mysql 9.6. So we have dt mysql here. Let's try to add that. SQL. Okay, we can try this. testdb. So let's do this. The test root apply. Okay, we can't. There is nothing here. So if I try dt mysql test, it is failing as well. Right, so DT MySQL definitely cannot resolve. These two containers are actually on default bridge. They can actually see each other by IP address. Let me show you what I mean. So now what I can do is basically I can actually inspect my DT MySQL, format JSON. Okay, so format JSON will actually tell me the whole MySQL information, right, in JSON format. So it is not very friendly. It's difficult to find. So what I like to do is usually I pair it with JQ. So when I do JQ, it will format it nicely. Technically, you can see all this information and you can hunt for your IP address, right? In this case, it's this IP address. Right? But usually, I prefer to actually do it like this, so I can actually filter it. I can remove this block first, right, by doing this. Then I can actually say I want to get just the network settings. Right, so it is a lot cleaner this way. So now I have the IP address. I can do this. Now if I test again, good. Okay, it's different, right? So now the error is basically because the public key retrieval is not allowed. So let's do the driver property here. We have a public key retrieval. Do we? Yeah, so we are going to allow it through. Then I can run, oops, oh my. The IP address again, okay, test DB, public retrieval, to run the test again, do this, apply. Yeah, now we can actually get connected. So it actually connects. MySQL does respond to that public IP address. So the default bridge actually does work. But I don't think we want to actually keep finding the IP address of containers, because once they start, it might be assigned with any other IP address as well. So that is definitely not ideal. When every time you run docker inspect, then we can update the cloudbeaver. So we don't want that. So how do we solve this? So what we want to do is basically we want to actually solve the DNS by the container name. Right? We can do this by something called custom bridge. On custom bridge, Docker provides built-in DNS resolutions for its container, so they can find each other by name automatically. Let's stop our containers and create our magical custom bridge now. So I'll do docker stop dt mysql. Right, both are stopped. Okay. Docker rm. I think I forgot to do rm earlier, but that is not a biggies. So let's create the custom bridge now. dt app. And we are going to do the same command again. We'll start here. Okay, so this time I'm going to remember to put rm. And I put another thing called network dt app. It's the same with the cloudbeaver. Right? So in cloudbeaver, I'm going to add the network dt app as well. That's it. That's the only thing that we change. Right? So we can check Dr. ps -a. Both are actually running for a while now. We can go back here. I'll go back to the ldocker again. Login, pgAdmin. Right, remember I don't need to actually create all this account again thanks to our CB data earlier. So I'm going to create new connection here, MySQL. So I can do dt MySQL, testdb, public key retrieval true. Then we run the test, to root, apply, we can actually connect. So I can create now. Login, and we see a testdb is created as well. Right. So this is the combination that we need. Right, we have a port mapping that gives us the browser access to cloudbeaver, and the custom bridge that gives the DNS between our cloudbeaver and MySQL. Okay, so let's take a look a little bit on the network. So we can do inspect dt app as well. Again, the same thing. There are too many things, so let's do a JQ. As usual, we strip off the front part, then we can actually look into containers. Right, you see that there are two containers here, cloudbeaver and dt MySQL, and you can actually see the assigned IP address as well in case you want to use the IP address, but we don't need that. Right, so let's clean up everything now. Right, you have nothing now. So now it's your turn, as usual. Right, so I have this exercise, right? So what I want you to do is basically I want you to actually wire up PostgreSQL and pgAdmin using a custom bridge network. The pgAdmin is a web-based PostgreSQL management tools. It's similar to cloudbeaver, but it's very Postgres-centric. So let's create, in this case, a dt stack. Then after that, I want you to run ddpg on dt stack with the name volume. Okay, you need to use this temfs, right? I'll let you know why later. So then after that, I want you to run pgAdmin, right, on the dt stack as well. And I want to port forward minus P8080 to port 80. I'll let you know why we need 8080 as well later. Right. Then you can actually log in using this account. Right. I want you to be able to do that. Then you add this and see whether you can actually resolve everything without the IP address. Okay. So you can actually pause your video right now and try it. Okay, let's go through it now. So I'm going to create the dt stack. Right, and I'm going to run the docker run ddpg. This is what we want, right, earlier. So the network is dt stack minus e post gress password docker minus e postgres db testdb minus v pgdata valid PostgreSQL data mfs var run post PostgreSQL, Postgres 17. Great, it is running now. Now, the temfs is basically the rootless requirement. PostgreSQL needs to write to the PID file to the var run PostgreSQL on startup. In rootless mode, that directory is not writable. So we have to give it a temporary in-memory file system on that path. Without that, Postgres will actually start silently but refuse any connections at all. So that's the workaround. The next one is basically the pgAdmin. We are going to connect it to the same network, dt stack -p8080 -e pgAdmin default email. Default password. Sorry, let's do pgAdmin _14. Okay, we have that, so we can actually open our web browser now. Oops. It is running now. So we created admin at admin.com. Then what do you use as password earlier? Oh, Docker. Allow me to log in. We are going to add new servers. So we call it dtpg. So we go to the connection. This one is dtpg. The port, they actually provide the correct one. The username, we usually use Postgres. Password is Docker as well. Yeah, and you can actually log into the testdb as well here. You can connect. Don't need to find out any IP address or whatsoever. Right, it's the same thing. So we can actually do Docker oops. So actually do the like this 1430. Oops, sorry, wrong one. dt stack. Right, so we have two containers, and this is basically a Docker networking done correctly. Let me just do a little bit of cleanup. pg, we don't need this anymore. pgAdmin. We have docker volume rm, pg data, cb data, with that as well. Docker network ls, docker network rm dt stack. Okay, let me quickly recap what we covered. The port mapping with -p will give you containers talking to your browsers. Custom bridge will actually allow you to give container name DNS by name. No IP address, no Docker inspect on every restart. There are few worth commands that worth knowing as well. Right, so you have the Docker network create, that is the one that will start everything. Then you can actually do the Docker network ls to list your network. Inspect will show what's connected, and rm obviously remove the network. Remember, Docker does not clean up custom networks when you remove containers. After long sessions, you can end up with a lot of orphans sitting around. So you can actually use a Docker network prune as well to remove everything. Now, if you remember, right, I was like kind of struggling to wire up just 2 containers. They are just 3 commands, but it is very long, right? The Postgres one alone is a wall of flags. Any typo just now would have break the entire demo. And when you want to rebuild, we have to type it all again. There is definitely a better way. On the next episode, we'll put all these commands into file. Anyway, if this video helps, hit like and subscribe. Drop any questions in the comments, and I'll see you on the next one. Bye bye.